Hello explorers and welcome to another video. Today we are doing some more Advent of Code. And it's day 7 and it's gonna be more interesting parsing of data here. It's a lot of parsing puzzles this year. So, you land at the regional airport in time for your next flight. In fact, it looks like you have been in time to grab some food. All flights are currently delayed due to issues in the luggage processing. Due to the recent aviation regulations, many rules, your puzzle input, are being enforced about bags and their contents. Bags must be color-coded and must contain specific quantities of other color-coded bags. Apparently nobody responsible for these regulations considered how long they would take to enforce. For example, consider following rules. Light red bags contain 1 bright white bag, 2 muted yellow bags. Dark orange bags contain bright white bags and 4 muted yellow bags, and so on. So it's a lot of bags and their contents. And they are written as strings here, so there is a lot of them to come. These rules specify the required contents for 8 bag types. In this example, every faded blue bag is empty. Every vibrant plum bag contains 11 bags, and so on. You have a shiny gold bag. If you want to carry it in at least one other bag, how many different bag colors would be valid for the outermost bag? In other words, how many colors can eventually contain at least one shiny gold bag? In the above roles, the following options would be available to you. A bright white bag, which could hold a shiny gold bag. A muted yellow bag, which could hold a shiny gold bag directly plus some other bags. A dark orange bag that can hold a bright white bag, a yellow muted bags, either of which could then hold a shiny gold bag. A light red bag, which could hold a bright white bag and muted yellow bags, either of which could hold a shiny gold bag. So in this example, the number of bag colors that could eventually contain at least one shiny gold bag is 4. How many colors can eventually contain at least one shiny gold bag? The list of rules is quite long. Make sure you get all of it. Okay, so this is gonna be an interesting one. First off, we're gonna create something that can parse the first input and create for the result for bags. So let's jump right into it here. Start up my editor. So this was day 7. Let's create another class here. Puzzle 7a. And I also think that we need to create a bag class. Let's see here. New Java class. Bag. And what could a bag contain? Bag could contain a hash map of other bag types, I believe. So let's say hash map, and then we have a string and an integer. So the first one is the type of bag, and then we have an integer of the amount of bags within that bag. So let's see here. Contains could be the hash map here, and we can just call it a map. Don't need to be a hash map. So that's the private thing. Then we have a public little constructor for bag here, which takes a string rule. So we will parse that rule, and then I think we should have a public boolean here contains bag, and as a string here as well. And if the contains key of this name here, we will return the result of that. So that's just check if the key is there. So we need some rule logic here, and then we need to do a lot of checking in our puzzle here. So first off, we need all this parsing logic once again. So let's create a main function here, add the parsing logic. We will have bags here. And I think we shall have a list of bags. So all bags, new array list of bags. So there we go. And yeah. So that's it. And for each of these lines here, we will create a new bag and add that bag into our all bags list. Like that. And then we will do some logic down here to get the actual amount of bags. But let's consider the parsing logic first. So this is the 7 test. So I have a test that contains the first rules that we have here. And we have some bags that contains no other bags. So that's interesting. We have something that contains some kind of bags. So, and we can also have something that contains a single bag. So this is a tricky one. So let's see here. These two, and I believe the last one here has pretty much everything that we need to take into account here. So these are contains no other bags, so those we could actually skip because they don't have any bags in them, so those lists should be empty. So what I want here, I also want this private string name we have here. So we will give it a name, and we will have a get name here as well. So we have a getter for that. So let's see here what we can do with this rule. So first off, we have some declaration, then bags. So perhaps we can create a pattern, p pattern compile, and then a string. So we do some regex here again. So first off, we have some characters. So let's say that we have anything here for a specific amount. Then we will have bags as a word and contains. And then here we should have a number of which could be 0 of some value that could be do we think that they could have multiple names, or is it just 2 words? It looks like we can take, we can call it one that is just 2 words all the time. We might be doing us a disservice by saying that they aren't 2 words. There might be 3 words, there might be 1 word, but it pretty much looks like everything is 2 words. So that might come back and bite me later, but I'm trying that one first. So then we could say here that we expect the first one here to be a word and another word. Or do we need to have them like that? And then this is the same. It contains 2 words, but we have a digit here, or multiple digits, like that. And we can have 1 or more of those which end in bag with a dot, or bags. Bag and an bag and an optional S and then either that or that. So we can put that into these. So either of those characters and an S there. So I think we can do like that. That should give us something nice. But I know there is something that calls regexp planet, which I use regularly to figure these things out. They are really good at handling regular expressions. And then we have our input here. So let's say that we have these 2 like that, and the next one like that. And we also want to have this one where we don't have anyone contains any other bag. What do we get then? So like that, put that in. So let's test this and see. So we don't get any matches at all. So perhaps the word is not correct. So let's see, pattern, Java, see what it says here. Word, a word character or a non-word character. Yeah, so that should be the correct one. So let's see here. A bright white bags, contain, and contains. Okay. So that doesn't really work for us. So this means that we need to have another approach here, but I think we can do this manually. So let's first off say that this bag contains is one thing that we want to split our string with, because bags contain is a value that we have every time. Let's go with that. So rule split bags contain, and we get a string array here. So this first one is the name, is equal to name, like that. And then we have another string here with the rule, which is the sArray1. So they take that rule here and print that out. X out. Let's see if we get just the second part here. Yeah, so now we have an extra space here, which is not required. So let's do like that. So we just remove all the extra spaces here. So there we have it. And then we will separate these by commas. We will remove all bag related things. And then we should be able to handle each of these specific rules. So let's see, we have a for loop where we have the string input string of rule split with commas, like that. And then here we will string replace and replace all. And here we will have a regular expression, which is bag with an optional s and either a comma or, let's do that, and then s out. So we get all of that. So why can't we do like that? Okay, we need to have the replacement string, which should be nothing. So let's see if we get that. What do we get? We get that, okay? And let's trim it as well. So we remove all the extra spaces here. So now we have something that we can parse. We still have some extra bags here. Okay, so there will not be any comma. So I think we will need to do like that. It's an optional dot afterwards. So now we have removed all the extra craft that we have here. So now we can use a regular expression. So this is matches. That's not really what we want. But we could also just now. I think the regular expression here is the safest one. So if we have a new pattern here, because it's a very simple regular expression, it's just some digits, and then we want to have some name, and then we want to have another one of these over here. So this will be our second group, and this will be our first group here, like that. And we can actually say a word character. It should be fine. So that will give us two groups. So if the p matcher of string matcher, and don't use any long variable names here. So if we find this here, we will take the group, the first group, and put that into, let's see here, we have integer and string, int number. So this integer parse int here, And the second group, we need to have a name here, so string name, and we don't want to parse that integer. And then we want to put that into our hash map of contains. So we will put the name and number here. And then we can system out this contains here, and the size of those perhaps could be something we can do after each rule input. And we need semicolons, of course, so we have a valid program. And we see here that we have 221.222.100. So 221.222.200. It looks correctly. So let's see here. How should this be done in a good way? Now we need to do the actual logic here. We have this contains bag, so that's something that is very helpful. So I think we'll need to do this in multiple steps. And we have all the bags. Then we will have a list of so we do a while loop here. While current bags. So let's do this current bags here. Current bags equal to all bags. Perhaps it's safer to actually create a new hash map here and then take current bags and add all of the all bags. Not hash map, of course, array list. So now we have the list of current bags, and it contains all the bags, while there's current bags. So it seems like this need to be defined above here, like that. So we will set it to a new, or we can do current bags clear every time. So we will clean it up and put all the bags in there. And as long as this size is larger than 0, we will continue. And here we need to find if the current bags that we have contains the specific name that we are looking for at the moment. So we now have all the bags there, and we also need a list of string names to look for. New array list. So as long as that is larger than 0 and this names to look for is also larger than 0. So there we go. So if both of these are larger than 0, we will continue. Or if either of them are larger than 0, we will continue. So, And here we will start by saying names to look for, add shiny gold. So this is the first bag that we will look for. It's the shiny gold bag. So that's what we have. And here we will have a for. We can't have a for loop because then we can't remove things. We need to do an all bags iterator. Iterator of bag IT. The good thing with an iterator is that you can remove things from the iterator as you are running through. So here, while next, we can say IT next, and we will get a bag. And then we check in if this bag contains the name that we are working with at the moment. So names to look for. Is there a good model where we can put things in and get things out simply? Is a stack perhaps a good one? Array stack, DQ, array DQ. Like that. DQ. So now we have added this shiny gold, and here, before we do this while loop, we will string get a name, and this is the names to look up for. Pop one name off, and if this bag contains this name, we will first off take these names to look for and add the bag name, and we will also increment number of bags. We will increment that number of bags as well, like that, and then continue. So here we will take the number of bags and print that out. We could say is empty here instead, might be nicer. And I think both of these needs to be empty. No, while, okay. While none of these are empty. That's what we want to see. We want to have things in them. Yeah. So if any of them is not empty, we will continue. Let's see what we get here, if we get the result at all, or if it will, no such element, remove first. Okay. So let's see here what the problem was. Let's go here. So here we have one name to look for. We will pop that name. We will go in here. Look, that did not contain it. That did not contain it. That did contain it. Okay, so we got a new name, two new names. And the problem we have here is that we don't remove any bags. So we need to remove bags as well. Let's see. So we did this loop here. We removed a lot of bags like that. And when we're done, we added all the bags up again. Why did it not add those bags into this current bags anymore. No, it's because I'm running it with all bags. That's incorrect. Let's see now. If we do like that, might not be. Now we get 6 bags. And that's not correct. We should get 4 bags, right? So what did we do wrong here? So first iteration here, we have 9 bags. We go through and see if they contain any of these bags. And we get 2 bags that contain this shiny gold bag. So that's correct. So now we have names to look up is bright white and muted yellow. So let's see here, bright white and muted yellow, bright white and muted yellow. So that's 2 bags that contain these, but they contain both of them. Okay, so we can't during this this phase we remove bags from the list that we want to check, but if we don't add any new names, we can't look up those again. So now we have a bag that contains both of these. So that's an issue. It's an issue. That was what I wanted to not have to be a problem for this iteration. Yeah, I think it is because okay, so if we are up here, if I think we need to separate this into different functions to make it more reasonable. So we want to have a function that gives us the name of all bags that contain the bag that we are looking at for the moment. So we have a bag name. We want to look at all the bags that contain that bag name. Let's just make that function. Public static list string get all bags that contain string name. So that's what we want to accomplish here. And we can also give it this list of all bags. So we have a list of bags here. Then we will loop through all those bags and just give us the names back. So let's create a list of strings here. Names, new array list, return names for bag in current bags if B contains bag name and names add B get name. So that's what we can do just to see what contains what. And then we will just do this as many times as we can. So while names is name size larger than 0, run through this. Okay. So let's see here. We have the names. Let's say that this is a list. Like that. Array list. So now we have all the bags here. And we will put in this shiny gold in the bags here. All bags. And one of the names. So for each string name of the names. We will look for the name in these and get all bags that contains. And put that into names. We will add all into names here. So after we have done that, then we will need to count the number of names. So int current or number of names. So let's do that. Number of names. We add the names size like that. And I believe that should be it. Could that be it? It looks much simpler and doesn't work. Let's see here next. Yeah, we can't add to the same list. We can have a new names here. Let's create that. New names. Add that. Check that. And then names equal to new names. So we just change it up afterwards. And now we get 6-1 again. Oh why, oh why, oh why? Is it because we get the same bags? It must be that we get the same bags. So there's new names here needs to be a set. And hash set. And this up here could be a set as well. Then we should not get any duplicates during this run. And we get 4, which we wanted to. This took a long time. So let's see if we do this with the real puzzle input. If this is simple enough to solve that one. Or if it crashes. That could be an option too. 280. Looks like a nice even number. 280. Submit. Not the right answer. Your answer is too high. If you're stuck, make sure that you are using the full input data and also some general tips on the About page. Ask for hints on the subreddit. Okay. So, how many bag colors can eventually contain at least one shiny gold bag? So let's see here. The result we had here was 1, 2, and then 3, 4. So it was these 4 rules that actually ended up having this specific option. So what we want is actually to run this and just add new names to this list. So go through each of these names, add new names, and then look, after everything is done, how many names do we have? So here we could be able to put all of these new names into this list. And let's see here, number of names. So let's say that if names size is not equal to number of names, let's see if that works. And then up here we set number of names equals to names size. So then it should run until they are equal. So then we got 193. Let's test it with our first puzzle here, the puzzle input. And we should get 4. We get 5. Why do we get 5? I really want to know what the names variable here is. It's because we have the shiny gold bag that we started this with, right? Yeah. So it should be 1 less than the value, which is correct. It's 4. And we can subtract that without any issue. So let's run this. And this was 193, so 192 might be the answer then. 192. It's right. You get a gold star. I get a gold star. Everybody gets a gold star. Nice. So what did I do here? Well, first off, we had this bag class that had a little bit of a rough logic to parse rules. We split bags contains up into name and rule. So the first part here was the name, and then we had some middle part here, and the second part here was the actual rule. Then we parsed that rule and created a pattern, splitted it with comma, removed extra crap, and then we just went through that, got the number and the string name here, parsed that out, and we created a contains bags and a name function. Then we created this list of names, or this set of names. We added the shiny gold name to it, and then we wanted to go through and see how many names we could create. So we start off with 0 names as our start value, but we already had added 1 name. So this statement here is true because they are not equal. We have added 1 name from 0 already. And then we go in here and say, okay, now we have added 1 name. Let's update that value. And then we will create a new name of a hashette because we can't change it while we are looping through it. And then we will loop through the old names variable and see how many bags that contains that name, and create a new set of all the bags that contains these different names. And that new set we will add to the current set. So then we will have an amount of new bags that contains the original bag. And then we do that again because these will not be the same. So we will go through it again and get a new set of bags that contains all the other bags and put that in. So we just add to the pile of bags that contain things. And it's important that we have a set so they are uniquely named. And then we will print out how many names that is. And because we had a shiny gold bag from the beginning, we will remove that from the set, which makes it 192. That's the result that we got. So let's go back here and see what the next part of this is. It's pretty expensive to fly these days, not because of the ticket prices, but because of the ridiculous number of bags you need to buy. Consider again your shiny gold bag and the rules above the example. Faded blue bags contain 0 bags. Dotted blue bags contain 0 bags. Vibrant blue bags contains 11 other bags and 5 faded blue bags and 6 dotted black bags. Dark olive bags contain 7 other bags, 3 faded blue bags and 4 dotted black bags. So a shiny gold bag must contain 1 dark olive bag and 7 bags within it. And the 7 bags within it, okay? Plus 2 vibrant plum bags and the 11 bags within each of those. So 32 bags. Of course, the actual rules have a small chance of going several levels deeper than this example. Be sure to count all the bags even if the nesting becomes topological impractical. Here's another example. Shiny gold bag contains 2 dark red bags. 2 dark red bags contain 2 orange bags, and so on and so on. In this example, the shiny gold bag must contain 126 other bags. How many individual bags are required inside of your single shiny gold bag? Okay, so we need to find all the rules for the named bags of shiny gold and see what other things are contained in that bag and get all those names and then multiply with the result of some other calculation down the line. So this can be tricky, very tricky. So let's see here. How do we do this in the best manner? I think we need to do a recursive function that gives us the result of this. So we will create, I guess there is only one shiny gold bag. That is what I think that we could see here. So if we create a new file here, which is the puzzle 7b test, and it's a text file, and we will change the name of it, so we will have the ending of txt and put that in there. So here we can read all these and we should be able to say find the shiny gold bag and then go through that bag and figure out what it contains. So let's see here. If we have that and we can see our puzzle input here, shiny gold bag. Let's see if we can find that. It's on one here. Let's see if there is another. So it looks like we only have one shiny gold bag. That is the first definition, which is nice. So let's do this. We have everything added here. So we will take our all bags and we will find the shiny gold bag first off. So let's go through this. For all bags as bag, and B, if B get name equals to shiny gold, so if that's name, then we will see contains number of bags, and then we will add all bags to that function. And here after this, when we're done this, because we only have one, we will break. So we will start with then a long of number of bags, and so this is 0. Here we will get that, or we can just system out this number of bags here, because that is the end result. So let's create this function here. So this function takes all of the bags, and we have something that contains here. So this contains is something that we need to loop through for bag, or for map entry string integer bag, and here we will need to first off find a bag within all bags. So let's have a function for that. It's pretty much what we have here. So let's put that into our bag function here. So this could be a private bag, find bag within all bags. Yeah, so we have this here. So we have all bags and a name, string name. So if it equals the name, we will just return that bag here. So that's the simple function of that. And this is the contains that we have here. And we want to have the entry set of that. So now we will have all the bags that we have here. And this is where it gets silly, because we have the long number of bags, which is equal to 0, and we will return it here, number of bags. And here we will take this bag and we will get the key first off. In order to find the specific bags, we have this find bag here with all bags and this key. So this is the new bag, the found bag. And the found bag, we want to take this found bag and see how many bags this contains with all bags. And then take that value and multiply that with the bag value and add that to our total and return. So as you see here, this gets very silly very fast, because this will be a huge number in the end. So we will find the specific bag, we will run this function recursively we will multiply every result with the bag value, which should be one integer of value, and we will get a huge number in the end, hopefully, or it will crash. And we had a missing statement here because we can actually not find it, and if we do, we will crash because we need to find each bag. So let's get the null pointer exception there. We get 0. That's a very curious number. Why do we get 0? Yeah, we need to count this bag as well, I guess. That's the problem. So we get 12,129 bags in total. Doesn't seem that much actually. So let's see here. It's too high, so I guess that we counted the gold bag as well. So I need to wait a little bit until I can answer there. So what did we do? We took our puzzle here and we found the first shiny gold bag, and then we will run a contains number of bags, and we start with 1 bag because that's the first number here, and this is the current bag that we are looking at. And then we will add the number of bags that it contains. And that is equal to the bag value, number of bags, and the other bags that it actually contains. So I think it seems reasonable to have this. Yeah, you get a gold star, I get a gold star, everybody gets a gold star. So we had to remove the shiny gold bag, of course. So this is what I wanted to show today and wanted to accomplish today. I hope that you found this video interesting. I hope that you learned something today. If you solve this puzzle in a different way, leave some code in the comment section down below, or just explain how you thought through this problem. If you like this video, give it a like, share it with your friends and colleagues. If you haven't subscribed yet, please do that. And I really hope to see you in the next video.